Welcome and thank you for joining. In this lesson, we'll look into naming organic compounds. We're going to start with one of the most famous groups of organic compounds, hydrocarbons. And I want you to pause for a second and think, what are hydrocarbons, or what do you think they are, even if you've never heard of them? So let's try to break this name down into smaller names that you probably are more familiar with. So as you can see here, we have hydro and we have carbons. So hydro, think of an element that starts with hydro. So this would be hydrogen. And an element that starts with carbons, and this is carbon itself. Okay, so hydrogen and carbon bond together to form organic compounds, and they can bond in many different ways. And that is what provides a variety of substances that fall into the group of hydrocarbons. So we're going to start with the first group of hydrocarbons that we call alkanes. So what are alkanes? Alkanes are a connection between carbon and hydrogen, and all alkanes are formed by using this formula. Or we can create their formulas using this general formula for alkanes, which is CnH2n plus 2. So what that means is that for every number of carbons, then we're going to say, let's say, for example, if the number of carbons is 5, then the number of hydrogens is calculated by using the formula 2 times the number of carbons plus 2. So let's get started. So we're going to name hydrocarbons from 1 to 10 carbons. So if the number of carbons is 1, then we're going to say that the number of hydrogens is going to be double of 1 and then add 2. And that will make this CH4. So the next hydrocarbon is C, 2 carbons, and we have hydrogen 2 multiplied by the number of carbons and then plus 2, and that will make C2H6. So in a similar way, we're going to form the next hydrocarbon on the list, which is C3, and then for the number of hydrogens, we're going to double the number of carbons, 2 times 3 plus 2, and that will give C3H8. And by now you probably recognize the pattern in how the hydrocarbons are formed in this respective sequence. And what we're going to do for the next one, we're going to try something different. So if you want to form the next hydrocarbon with 4 carbon atoms, then we're going to say that the number of hydrogens, as you can see here, it is going up by 2, so C4H10. The next one will be C5H12, and every now and then double check if it fits the formula. So 12 must be double of 5, so that's 10, add 2. So next we have C6H14, and then C7H16, C8H18, C9H, 9 times 2 is 12 plus 18 plus 2 is 20. So 20, and then C10H22. Now we're going to get to name now each hydrocarbon form. Now remember that because these are called alkanes, so all the names will end with anes, okay? And based on the number of carbons, the name will have a specific prefix. So for 1 carbon, we have the prefix meth. 2 carbons, eth. 3 carbons, prop. 4, but. 5, pent. 6, hex. 7, hept. 8, oct. 9, non. And 10, dec. So next we are going to add the suffix of anes. So ane, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So next we're going to move on to the next group of hydrocarbons that sound similar to alkanes, but they're slightly different as well. So we call them alkenes. So the good news is that the naming and the formula, so creating their formulas, works in a similar way, but for alkenes, we follow the pattern CnH2n, which means that the number of hydrogens will be equal to double the number of carbons, which makes this a lot easier. So if you have one carbon, then you are going to have double the number of carbons in an alkene, so that's 1 times 2. Next, we're going to have 2 carbons, so we have H, and then we have 2 times 2, 4, and then C3, H6, C4, H8, C5, H10, C6, H12, C7, H14, C8, H16, C9, H18, C10, H20. Now let's start with naming. So the prefix will be based on the number of carbons. So this is going to go meth, eth, prop, but, pent, hex, hept, oct, non, and dec. So next we are going to add the ending, which is going to align with the ending of the word alkenes. So these are ene hydrocarbons. So all of them, all the names will end with an ene. So methane, ethene, propene, butene, pentene, hexene, heptene, octene, nonene, decene. Okay. Now, the last group of hydrocarbons that we're looking into is the group of alkynes. So I would encourage you to try this on your own because in principle it works in the same way as naming alkanes and alkenes. But this time we're going to use this very special formula, which is CnH2 and minus 2. So what that means is that the number of hydrogens now is calculated as double the number of carbons subtract 2. So we're going to start with the first one together. So if we have only one carbon, then the number of hydrogens will have to be 2 times 1 minus 2. So that would be like CH0 basically. So we don't have methane. So next we're going to go with C2, H 2 times 2 minus 2. So that will make C2. Let's write this nicely. So C2, H2. C3, H 3 times 2 minus 2. That's 6 minus 2, 4. So C3, H4. C4, H times double of 4 minus 2, that will make a 6, so C4H6. And now you can basically see the pattern, so all the number of hydrogens are increased by 2 and carbons increased by 1. So you have C5H8, C6H10, C7H12, C8 H14, and double check just to be sure. So 8 times 2, 60. Take away 2, 14. So we are on the right track. C9, H16, and C10, H20. Now let's start with the naming. So here we have just carbon, so this is not going to work. So I'm going to continue with 2 carbons. So eth, prop, but, pent, hex, hept, oct, non, and dec. And lastly, we're going to add the ending of this group of hydrocarbons, which is the group, the ine group. So we're going to say this will be ethine, propyne, butyne, pentyne, hexyne, heptyne, octyne, nonine, and decyne. And this is how we name this group of hydrocarbons. I hope you found the instructions useful and easy to follow. Bye for now.